Alright, today we'll be studying decimals, which is another way to represent numbers that are not whole counting numbers. So not just the ones and twos and threes, but all the in-betweens like fractions, which we've been doing. Decimals is just another way of expressing those numbers. So we'll begin with a number line, and we're going to focus first on just this little piece between 0 and 1. So let's enlarge that. And we're going to cut this interval between 0 and 1 into 10 equal sections. Okay, and then the numbers between 0 and 1 will be given the labels 0.1, 0.2, 0.3, all the way up to the 1. Okay, so what does it mean when we say, for example, 0.7? Well, remember, there were 10 equal sections between 0 and 1, so it'd be a fraction out of 10. And then 0.7 goes this far, which really is made up of 7 of these sections. We can count them here. And so that means that we've got 7 out of 10, and that's what 0.7 means. Okay, so like when we did like place value way early in this year, we can see that the 7 holds a value of 7 out of 10, and so we say that the 7 is in the tenths place. Okay, any digit in that place would be worth that much out of 10. Alright, so let's zoom in a bit further, and we're going to go between 0.7 and 0.8 here. And we're going to cut that little section into another 10 bits. Okay, and so that gives us the decimals 0.71, 0.72, 0.73, and so on, as you can see there. Okay, so let's look at one of them. Let's say 0.74. What does that one mean? Well, you can see how the 4 is telling you how far to travel from 0.7 to 0.8. So you might know that 0.75 would be halfway between 0.7 and 0.8, and 0.74 then would be a bit under halfway between 0.7 and 0.8. But let's get a little more precise here. So we'll zoom back out to the whole interval between 0 and 1. Now remember, we cut this section into 10 equal pieces. That was the meaning of 0.1, 0.2, 0.3, and all those. And we had to zoom in on one of those sections between 0.7 and 0.8 and cut that guy into another 10 pieces. And really, we're doing that to all of those sections. Right, so how many pieces do we have altogether? Well, if each of the 10 pieces is cut into another 10 pieces, well, 10 times 10 gives you 100. And so what 0.74 is actually worth is it's a fraction out of 100, and it's 74 out of 100. Right, now we say that the 4 now occupies the hundredths place, because in that place, the digit is worth only 4 out of 100. Okay, we'll get rid of those hundredths marks for now because it'll get a bit cluttered otherwise. And we want to start comparing decimals. That's what some of our work today will be about. And so let's compare, say, 0.74 and 0.9. Now you can see it quite obviously here right now that 0.9 is bigger. But sometimes when you forget the picture, what we often see is people think that because 74 is bigger than 9, that 0.74 is somehow bigger than 0.9. Now again, you can tell from the picture right now that that's not true, but let's be clear on what's going on here. Just the 0.7 part would be over here. Then the 4 part again tells you how far you need to go from 0.7 to 0.8. So it's only telling you how far to crawl across there, and we saw that was a bit under halfway to 0.8. Okay, so there is no way that that could be any bigger than 0.9 because anything you put after the 7 only tells you how far to move from 0.7 to 0.8, but no matter what you put there, you're never going to get past the 0.8. Okay, so that's why 0.9 must, of course, be bigger then. Okay. Now, another common mistake we see, maybe not as common, but what we sometimes see when we start doing conversions between fractions and decimals, which we might do properly next time, is that when people see a fraction 2 over 5 and it needs to convert to a decimal, they sometimes just say 2.5. Right, now we get a bit upset when that happens, right? Because, well, it's wrong, but 2.5 is over here, right? Whereas 2 over 5 is a very different number. Now, what is this number? Well, if you multiply both top and bottom by 2, you'll find that 2 over 5 equals 4 over 10, which is 4 in the tenths place. So as a decimal, it must be 0.4. Now, 0.4 lives all the way back here, right? This is really where 0.4 is. So, of course, they're very different numbers. Okay, so please don't just think that you can convert between fractions and decimals by just grabbing the same digits. It doesn't work that way, right? And we might do these conversions a bit later, but just know that that doesn't work. But for now, let's see a couple of examples of comparing decimals. So we'll go with 0.847 and 0.86 and ask which one is bigger. And the way you compare these is you'd look from the left and you would compare the digits at the same place. And so here we're looking at the ones place and they're both 0. So we go across to the tenths place and they're both 8. So that those are both worth 8 out of 10. So right now, it's all the same. Then you move across to the hundredths place, and you see that, well, the 6 is bigger than the 4, and that's enough to tell straight away that this decimal 0.86 is bigger. Remember, we can use this symbol to say that 0.847 is less than 0.86. That's what that symbol means. Okay. What about 3.505 compared with 3.0555? Right, so again, we start by looking from the far left, and we look at the digit in the ones place. That's as far left as we can go. They're both 3, so we'll move on to the tenths place. And we see that the one on the left has 5 tenths, whereas the one on the right has 0. And we can stop here, right? Because no matter what happens after this, the one on the left must be bigger, because it's got the larger digit in the tenths spot there. Okay? And so we can once again use this symbol to represent the fact that that decimal is bigger. So in general, we find that the digits on the left are more valuable than the digits on the right. So when we're comparing decimals, what that means is that you can start from the far left and you're comparing digits in the same place as we just saw, and we can sort of scan to the right until we come across the first digit that happens to be different between those two decimals. Now, once you come across the first different one, that should tell you straight away which decimal number is bigger, and you don't even need to look at the rest of the digits. Once you've found that first different one, that tells you immediately which one's bigger. Okay, so that's comparing decimals. Thanks for watching, and I'll see you next time.